Good morning, my dear students. Today we are going to start a very interesting chapter of science, that is gravitation. You know, the gravitation was that phenomena after which the science was completely changed. The discovery of gravitation pulls the interest of the people towards science. Okay, gravitation. Have you ever wondered why the earth is just hanged on a blank space? Or the space has nothing at all but is still hang the earth without any support? Or have you been thinking about the fact that when you throw any object just above the ground, it returns back again to the ground? You know, this happens just because the ground is attracting that object that you have thrown just above the ground. In this universe, every particle of matter, whether it is the particle of very small objects or whether it is the particle of very large of bodies like the sun or the particle of the Jupiter or the particle of the earth or the particle of the moon, every particles of matter in this universe attracting the every another particle in your surroundings. All the things that you are watching in your surroundings, that you are viewing in your surroundings, all the matters are exerting some attractive forces on you too. All these surroundings of me, all the objects surrounds me is exerting some of the attracting forces on me too. Okay, so the force of attraction is happening, the force of attraction is happened between the every particle of matter, and this phenomenon of attraction, the phenomenon due to which every particle of matter attracts every another particle, this phenomenon is called the gravitation, and the force of attraction between the particles is called the gravitational forces. Okay, the force of attraction exerted by the sun is the gravitational force of the sun. The force of attraction exerted by the moon is the gravitational force of the moon, and the force of attraction exerted by the earth is the gravitational force of the earth. The gravitational force of the earth has the special name that is the gravity. Okay, so moving forward, from where this force of attraction came? This force of attraction comes naturally, occurs naturally. Okay, like a magnet attracts iron like object naturally, the same way every particle of matter attracts every another particle naturally. There are only four fundamental forces in nature, and all the four fundamentals are a strong neutral force, a strong nuclear force, that is the SNF, weak nuclear force, electromagnetic force, and the gravitational forces. Among all of the four forces, the strongest force is the SNF, the strong nuclear force, and the weakest force in the nature is the gravitational forces. The gravitational force depends upon the mass of the body and distance between them. So it is always experienced with a body that is larger in mass. It is always experienced with moon, with sun, with earth, always experienced and seen with that bodies, the big bodies also, because it is the weakest force in the nature. Okay, so who discovered this important, this interesting phenomena? This interesting phenomena was discovered by a great scientist at that time, that was the Sir Isaac Newton. During the mid 17th century, Sir Isaac Newton was also facing the lockdown like we are facing at right now. All over India is getting locked down due to the COVID since 2020. The same way, all the Europe was closed due to the plague at that time during the mid 17th century. And this quarantine period, Newton changed this quarantine period in a very interesting way. He changed this into an opportunity and discovered the three important phenomena of physics, that was the calculus, that was the optics, and the last one was the gravitation. Okay, so what was the gravitation you have already studied. What was his laws? Newton's formulated the laws of gravitation, and the laws of gravitation was, he states that the force of attraction between the particles is directly proportional to their masses. Directly proportional means directly proportional to the product of their masses. Means if you are increasing the mass of any one of the objects, the force between them is getting increased. If you are increasing the mass of the first object 2 times, then the force is also increasing 2 times. If you are increasing the mass of both of the object 2 times, then 2 into 2, the force of attraction between them will be increased by 2 into 2, 4 times. And the force of attraction between them also inversely proportional to the square of distance between them. That means if you are increasing the distance by 2 times, then the force of attraction between them will be decreased by 1 by 4 times. If you are after comparing the equation 1 and 2, we get the formula of force between two particles, that is F equals to m1 m2 upon r square. what we have done there, we have just removed the constant sign, we have just the proportionality sign and put a constant over there, because whenever we remove the proportionality sign we must have to put a constant over there. And where the constant, the g is used, is the universal gravitational constant, and its value is already discovered. Its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Sometimes the question is asked, what is the unit of capital G? So the unit of capital G is Newton meter square per kg square. Now let's do some numerical questions. Let's do a single numerical question with this formula. Okay, RT, and I have already, this is the question of NC. So this is the question of NCRT, and the mass of the earth is already given, the mass of the moon is already given. That means you already know the m1 and m2, and the distance between them is given. G, the value of G is already given. Okay, what you have to do, you have to just put this value into the formula. Now the calculation is a very large, that's why you can take this calculation 6.7 as the 7, you can take it 7.4 as the 7 that I have taken into the questions, into the solutions. Okay, so 767, when you multiply this 7 into 6 into 7, you will get 294 by 16, then you will get the 18.37. 18.37 into 10 to the power minus 19, or you can write it as 1.8 into 10 to the power 20. So we have taken the approximate value. So approximate value of 1.8 is 2. That's why the answer will be 2 into 10 to the power 20. What is the force was there? So the 2 into 10 to the power 20 Newton. Okay, do these questions, and if there is any doubt you can let me know. Okay, so thank you for the session.